Hello, my name is Rick Fulweiler. I'm a Chief Solution Architect within the Office of the CTO from NetScout Systems. Today, we're going to spend a little time speaking about how to advance 5G network security by leveraging AI and ML technology. It's very obvious that enterprises today are very aware of the impact of 5G. In fact, looking at the percentages on this chart, you can see that the overall view of 5G versus 4G to them is quite different. In fact, 5G brings some very interesting key tenets, such as ultra low latency and high bandwidth, that bad actors, or as we may say, bad security actors, can obviously take advantage of. This is why that 62% of the businesses are worried that 5G will leave them really more susceptible to cyber attacks. But we will discuss not the classic attacks you might be thinking of. We'll be looking at other different types of attacks that you may not be aware of that's taking place today by leveraging these key 5G tenets. When we think about the overall classic maturity cycle of the protection systems that are there today, it's obviously improved quite a bit over time, and thus they've provided really pretty good protection for the mobile security operators. However, those classic solutions are just not aware of when valid devices, such as handsets or IoT devices attached to the network, then start acting out of norm. Actually, they're performing abnormal behaviors, such as, say, maybe IoT devices have been compromised, and those IoT devices are now collecting very sensitive data information in its location, and then not sending it obviously back to its home server any longer, but sending it to a new location that's been reprogrammed into the IoT devices. Or what about handsets? Handsets that are obviously valid to attach to the network, they haven't been banned, they can attach to the network, but once they attach to the network, there's something that's been reprogrammed into them. Obviously, some type of malware has infected the handsets, and now they're creating massive signaling storms inside of the 5G network, causing massive state exhaustion, directly attacking some of the 5G core network infrastructure. These attacks go after the 5G infrastructure and exhaust network resources. And these types of attacks are really the most expensive types of attacks for the carrier and for their business. It's very obvious that carriers today are leveraging their massive investment they've made in the 5G network environment to attract new enterprise customers and services. But as the enterprises place their most valuable applications in the hands of the carrier's MEC, they expect very specific SLAs on each slice, and they also expect a very specific level of security they want the carrier to provide that does not obviously impede or prohibit the use of their applications. Along with that, the average users of those applications today will depend upon them much more than they've maybe had in the past, potentially down to the dependency of their own life or those of their family. Thus, they need to be assured that they can trust these applications, that they are trustworthy and secure. So this really calls out for an advanced security detection engine that can see within the 5G network. As I noted, when we look at traditional methods of security detection, it does well for what they're designed to accomplish. But as you look at this on these detections on this slide, they're generally too late, are not really viable methods to see what valid but still malicious attacks take place within the 5G network. For example, outbound DDoS attacks at the exit point. Generally, it's really too late. The damage is already done. Internal 5G network services have already been attacked. Or what about endpoint device behavior within the network over control plane or user plane? So we will not see this if we're just looking at the edge of the 5G network. We need to see deep inside of the 5G core. And if you only look outside of the network, it's not possible to leverage the control plane and user plane data to provide complex mapping back to an infected endpoint IP address down to the subscriber, device type, or location. Only looking at internally the 5G network can you derive and correlate this information. Case in point, trying to identify very specific abnormal or unusual behaviors within the 5G network that relate to compromised devices is very hard to discern by a human without understanding the concept of security outliers. Therefore, having very specific AI and ML algorithms that look at how devices are behaving differently from their peers, such as performing peer analysis and maybe even using ranking algorithms such as value z-score, mobility z-score, or isolation force for abnormal detections, all these are needed. Key metrics driven from 5G core data and dimensions directly from the packet level data is needed to feed these AI and ML algorithms, which are also then trained with deep security domain knowledge. So the recipe is packet level data, very specific AI and ML technology algorithms embedded with security domain knowledge provides really the best result. The result of not doing this type of very sophisticated recipe can cause serious business impact to the carrier and also to the commercial customers that are writing and leveraging the carrier's network. Feeding the security detection engine with 5G network packet level data enables the solution to proactively, through leveraging AI and ML technology and automation, find and mitigate these issues faster before they start to reduce services or have major impact on the 5G network infrastructure and the 5G network services being provided by the infrastructure. Thus, both user and control plane data can be fed into the AI engine, drive these advanced correlation algorithms, looking at the network holistically, RAN to core and to cloud, a complete in-through-in detection view. So when we discuss 5G packet level data, we're often asked, where are the key monitoring points? So on this slide, what I've done, I've delineated 3 key major areas that we're looking at: user endpoints, RAN and backhaul, and services. And when we speak of services, we're talking about control plane services and the IMS part of the network also. Each one of these key points that we're looking at are a vulnerable point in the network where we can derive information that is key to feeding our AI detection engine. So when we take the AI and ML technology that we've talked about and couple it with deep domain knowledge of mobile security, we can see on this slide a small representation of potential threats that we can detect and mitigate that would also be impossible for humans to see these specific anomalies or unusual behaviors. So for example, a simple message, SIP message floods that overwhelm the network infrastructure resources. Direct attack on the 5G network resources. Attack that terminate ongoing calls in progress. This would be using by messages, or what we consider by flooding attacks. Or how about SIP registration hijacking? Or what about the fact that we're looking at DNS tunneling? This is traffic that's masquerading in DNS requests. Generally, what we see is these requests that are encoded with malicious data of other programs or protocols hidden in the DNS query. Or what about spoofed source address detection? This is identifying UEs sending traffic not using their allocated IP address. And this is key in the battle against DDoS attack, vectoring, leveraging reflection amplification. So these are just a few noted on this slide. There are many more that we're looking at and being able to detect with this engine. So when we bring it all together, we have a threat detection engine that leverages the smart data attained from modern to 5G RAN, the user plane, and the core, and the control plane. From any network vendor environment, whether it's in a VM environment, whether it's a virtual function running in containers on K8, and on any public cloud provider or the carrier's private cloud, a true visibility without borders strategy, which is feeding into a very specifically trained AI and ML algorithms with security domain knowledge. It then protects the carrier's infrastructure and services and user endpoints from the threats within. So lastly, as we try to close this AI loop by providing specific information of devices directly back to the PCF function, we can leverage its policy control logic to feed specific actions directly back into the SMF. So there you have it. Embedded 5G security, AI and ML detection driven by packet level data that protects the network from within. Thank you.